Hey, hello, and welcome to Show and Tell. It is your surprise guest host. Maybe not so surprising if you saw a blog post earlier, but it's me, John Park. I'm not Phil and Lamore. I'm me. It's me, and I got Lars back here, and Lars is trying out his high heel shoes there, his platform shoes. Way to go there, Lars. And what is this? This is Show and Tell, where we show stuff and tell about our stuff. It is some people from Adafruit. It is some people from the community. We're all going to take a couple minutes and show off our projects. If you have any interest in joining us, head on over either to our blog. We've got a couple posts from earlier in the day, or over to our Discord. If you take a look over at, actually, you can just go to adafruit.it/Discord. It'll take you to a Discord link. And then look for the live broadcast chat channel, and there you'll see a link that I put in that will get you right on over to our show and tell on StreamYard. You just don't want to have a microphone and a camera hooked up to your browser. And we will take a couple minutes, show some projects, and then we can all get out of here and prepare for Ask an Engineer, which is going to be happening in a half hour at 8 o'clock Eastern time. So let's see. Yeah, I'll do something slightly unconventional and do a little bit of a show and tell, which is not usually what the host does, but what the heck. So I've actually got two flavors of the LED platform shoes that I'm working on, and I will show those tomorrow in more detail on my workshop show. But one of these uses a sort of standard phone battery. One of them has a slightly more complicated setup using a power boost and a LiPo for some easier charging and switching on and off. But that is just a little tease more than a show and tell. That's what I'll be showing tomorrow on the workshop. So next up, let's bring on some people from Adafruit and the community. So how about Brent?
Hi, John.
Brent?
Hi, Lars.
Oh, hello. What's
You
going
wanna
on?
are those audio reactive, the shoes that you just showed?
Yeah, yeah, they are.
Whoa,
These,
where's the
these
microphone?
ones, there. It's actually buried inside of there, yet still, thanks to physics, it works fine. There's a little
Wow.
analog microphone built onto the Sparkle Motion board, and these are actually pitch and it's like FFT, so it'll
Yeah.
actually, if you have some music on, you'll see higher pitch stuff do different colors.
Oh, those
So
are awesome. I was
yeah.
curious how it was picking up audio, or if it
Yeah,
was
I
picking up
didn't
audio.
know if I'd have to drill a hole or run a mic out, but it's seeming like it'll work without too much effort, which is a nice bonus.
Oh,
Uh,
there's your show and tell.
there it is. Yeah. So what
Yeah.
do you have here? What's going on the
Yeah,
screen?
so I've built this little like sensor node, and I built so many of these. It'll focus, I think it's the blur filter that's sitting on it. Yeah. So this is like a cutie pie sitting inside a little enclosure,
Uh-huh.
and nothing's gonna focus because I have everything
That's
blurred.
easy.
But there's an OLED display, and then let me see if I can unblur. I think that will help me out here.
Yeah,
Background
that'll
off.
probably help.
Now
There
you
you
can
go.
see my really messy office.
No worries.
Um,
Are you kidding? Look at this place.
so it shows like the temperature, humidity, the TVOC, and it shows this on like a nice little LCD. Like this is one of our OLEDs. And there's a
Uh-huh.
sensor, so it's like a small enclosure. But what's interesting is, so if you go back to the panel as well, or like the screen to show it.
1 second. There we go.
Yeah, yeah. So we have like this is Adafruit IO. This is the device running Whippersnapper. There's no programming. You just load the device on. You can interact with it and add components. We have some new components, notably the OLED. So if I just write like show and tell and use my finger to like really reach there, it automatically writes it out to the OLED, which isn't
Excellent.
totally visible right now. So yeah, so we have these new components that are I2C output components. The one I'm showing on this is the 128 by 64 OLED, and then we also have the smaller one, which is 128 by 32. We're supporting the alphanumeric displays that are really nice. These 4-digit segment segs, the character LCD, so like the 16 by 2, then the 20 by 4. And then you can add all of them to your device, like there's already sitting in here. So if you want to 7 segment, you can add it. You can choose your text alignment for whether you want things to align to the left or to the right. And
Really
they
nice.
work really well. And then they pair beautifully. I'm writing a guide right now for this project with this actions blockly redesign.
Mm-hmm.
So what I'm doing is I'm just taking it, and every 15 minutes, I'm setting some variables to the sensors. So like the sensor values get set to a variable, and then I'm just rounding them to reduce like the decimal points that show up on the
Mm.
display.
Yeah, that's
And then
great.
I'm just doing this one big block
Oh,
where
perfect.
all I do is I type like the first line, and then I did this where like we delineate lines by doing like /n. So this block does it for you, which is cool. It's called the paragraph block.
Mm-hmm.
And then we template it. So it's like, here's the temperature variable, and then here's the humidity variable, then TVOC, and then it all lines up on the display.
That's really cool.
And yeah, and it works this way for um like the OLEDs, and the character displays will be like the new lines and really fancy.
Mm-hmm.
And the like alphanumerics and like the 7 segs all work this way too. So you can just like everything's treated as a feed, right? So you can just take the feed and like set the feed to whatever value you want.
Mm-hmm.
And it's cool. We haven't been able to really do display on Whippersnapper and Adafruit IO until now, because now we have this new like system where you can like build things dynamically. So like this
Yeah.
whole thing, no code, took like 15 minutes to set up,
Yeah, that's really
and
impressive
it's
because
really neat.
there's so much. Like I tend to do a lot of CircuitPython, and there's just so much sort of boilerplate setup that you have to do with displays to get things up on screen. Thankfully, things like Claude make it a little faster, but I don't think I've run across a sort of drag and drop blockly style uh, interface where you can do display stuff, because there's so much behind the scenes to get things working, as well as what
Yeah.
interface do you use to talk to it. So that's pretty impressive.
Yeah, this is a first attempt at it, and there's a lot more. And then like it's all within this interface. So like if you want the weather, you can pull the weather onto here and
Yeah.
do like all types of projects very, very quickly to build them and like validate them.
And what
Yeah.
state is this in as far as
Yeah. So
what's rolling out when, that sort of question? When can
when
people
the
use it?
guide is out, this will be out. So if you see
Oh,
the
great.
guide, which is probably out sometime in the next few days,
Yeah.
this will be out. I'm hoping
Oh,
to get it
great.
out by the end of this week or early next week, and people can
Amazing.
start playing immediately once it's out.
Oh, yeah. That's really cool. Lots of people in the chat also excited about displays. So you
Awesome.
struck a nerve. Very cool. Great work.
No problem.
Thanks so much,
All
Brent.
right,
We'll
cool.
see you
Bye,
soon.
John.
Bye.
Bye, Lars.
Ooh, hey, whoa! What have I done? Hey, I brought on Tim, and I there we are. I was just clicking things. I think Brent disappeared, so when I went to, but either way, hey, hello, Tim. How you doing? What
Hey,
is going on
GP.
here?
I am doing pretty good. Yep. So I have got the video game Factorio loaded up on the right half of my screen, and then I got my camera here with this nice industrial machine starter button thing that I bought offline.
Nice.
And I have been working on integrating the two together. I'll show you real quick inside the button. It just has a Pico W, which is wired up to the buttons, the keys, and then there's some pins that are broken out down here, and I'll show you what we can do with those here in a minute. So Factorio is a game about automation and building, and kind of the way to beat the game originally was to launch the rocket. So there was a lot of fanfare around the rocket. I figured that would be a good exercise of this. So I have it set up where you have to turn the key. That puts it into like an armed mode. It will turn these buttons green, and then you can push the big green button. That will start like this 10-second countdown timer here, which these will light up. We can always cancel during that. So if I press the stop button, it will cancel. It will turn all this stuff red. You have to twist that to pop it out, which is super fun. You got to put the key back and turn it again, and then I'll let it go this time. So it'll do its 10-second countdown. And then if everything works correctly, it will launch the rocket for us. And then I'll show you one other thing we can do with it. So yeah, there it goes. It takes a second to fire up, but then we'll see like its little boosters shooting off there, and then
great.
it will take itself off and go launch and park at my my space station up there. So for anyone that doesn't know, excuse me, Factorio, it's got this whole logic system built in where you can manipulate signals with math and decider combinators. You can do logic like if this, then that, all kinds of stuff in there. And so I really wanted to make this general and hook up. So I actually did this project with the button a little while ago, but I have renewed interest with it now. And I wanted to make it so that it's easy for other people to replicate and easy to do other stuff with.
Right.
Like this button was my first idea. But once we get the signals moving back and forth, then there's like all kinds of stuff you could do with this. Like you could have it check in on your resources in the game. Like coal is a thing. You have to have power plants and all this stuff. So you could have it set up to where like, if you're almost out of coal, it could like flash red lights in your room or something. So you know you're about to run out. So the buttons show getting signals from the microcontroller into the game. Yep. And then these ones down here will show getting signals from the game out to the microcontroller. So I have some NeoPixels hooked up. And then I have red, green, blue signals here. And I can actually just go in and just like CircuitPython or anything else, I can set 0 to 255. We can turn those colors on. And of course, I'm just setting these ones manually, but there's like a whole Turing complete thing inside the game. So you could build this as complex as you wanted with dynamic signals and all kinds of stuff.
That's great. So explain to me the direction from game out to microcontroller. What's that look like? What software and hardware is in that path?
Yeah, so it uses a mod in the game. So I created a mod in the game. That's another thing about this game. It's very developer friendly. You can write mods with Lua. So I created an MCU microcontroller write combinator. This one will send whatever signals it sees. It will send them out to the microcontroller. And the way that works is the mod also has a custom command, which gets run from some Python code technically that lives on the microcontroller over here. I have the actual PicoW hooked up, and it will actually send commands over USB to my computer. And then I have this Python code on my computer that's just listening for the USB commands. And whenever it gets any data over USB, it just turns around and sends that same data over this protocol called Archon, which is built into a lot of video games, including Factorio, which is just like a remote console, essentially. It lets you run commands as if you were at the keyboard, able to just type it in right there.
Oh, that's really cool. So it's just sort of serial commands that go from game through your mod over to the Pico, which then decides to turn on LEDs or whatever you.
Exactly right. Yep. And then there's one input combinator, a read combinator, and then there's one output, the write combinator. So you build whichever one you want, whether you want to get signals from the microcontroller into the game or signals from the game out to the microcontroller. You can do both of those and configure it up.
It's really cool.
Yeah, thank you. I'm super stoked to get it working, and I'm also super stoked to get it written up. I think I'll make a playground with this.
Oh, good. Yeah,
we'll have links to the guide and how to get everything set up and running. So
it's really cool.
Yeah, thank you.
Yeah, maybe do up a blog post once that playground is up, so that you can show that to people on the Factorio subreddits that I imagine there are many of.
For sure, yeah. That's the other hidden motivation here, is to kind of use this as a bridge between the Factorio world, which does have a large community, into the CircuitPython and microcontrollers and stuff. I think we can get some eyes of some folks who might be interested in this kind of stuff.
Fantastic. Really cool. Great work, Tim. Thank you for bringing that on. I love it. Really great.
For sure. Yep. Thanks, JP. Yeah. See you later.
All right. Really cool stuff. Next up, we've got Boian Mitov. Let me bring Boian on. Hey, Boian. How are you?
Hey, John, pretty good. Thank you. And yeah, a couple of weeks ago, I was showing how I was adding matter. In this case, ESP32. I ended up doing the ESP32 first. But here with this, I mean, it's connected to my Android device. And as you can see, I can control the on and off on the ESP32. And I will quickly show you. Let me share the screen and select the right screen to share. You can see it, right? Hello?
Sorry about that. Can you see? Can you hear me now? Yeah, your screen is up.
Yeah. Were you able to hear and see what I was showing?
Yes, looks good.
Okay, fantastic. So yeah, I'm showing the screen, and we'll do a quickly similar type of project. And we'll use a dev board for this. Select the board, and here in modules, as soon as it gets updated, the screen is a bit slow to update when the broadcast is going. We'll add endpoint to the Matter. And of course, we'll have to set up access point for our Wi-Fi because in this device, Matter requires that. So I'll add access point. And once added, here you have to set up the password SSD. I'm not going to do that. And that being said, we have our device here. I can hook it to a pin where there is LED. And I have it done. That's all it takes. And on the subject of display, I will quickly show you how I did the display because you were interested in graphical access of displays. Viuino supports them and supports a large number of those displays, including this core. Oops, wrong screen. So select the core, the ESP. Yeah, let's do the same core that I selected here. And give it a second to update the modules. And here is our TFT display. Of course, I can just send the simplest thing I can do is I can take a pin, doesn't matter which pin, and just send it to the display, and that's it. The display will start working. But if I want to be more fancy, what I can do is I can add a text field. And then that text field, I can specify the location of the text field. And then I can monitor a specific value on that text field. That's how I did this particular one. Those are just text fields. So that's what I wanted to show. And now I'm working to add also support for the Matter, for the Arduino Matter. I kind of decided to do the ESP32 first. Yeah, the ESP32 is done, and now I'm working for the Arduino Matter. That's what I have to show.
Thank you so much, Boian. Appreciate it. We're looking good.
Welcome. Thank you.
Thanks. All right. And let's see. Last up, we have todbot. Howdy, Tom.
Hey there. So hopefully this week, compared to last week, will be a little bit better. Hopefully my OBS setup is good. So as I mentioned last week and previous, I've been working on a sort of CircuitPython version of what this is a recreation of, which is the TB303 bass synthesizer. If you've heard electronic music that goes like blurpy blurpy blurp, it's this. Yeah. It was this little tiny Roland synthesizer that came out in the late '70s that then got repurposed by electronic dance music in the, I think, early '80s. And so it's got a really interesting little simple synth architecture with a really interesting sequencer that has things that normal music sequencers don't have these days, like these accents and slides. And so I've been trying to recreate that. Mm-hmm. And I'll shoot to a down shooter here. So this is the current sort of like state of things. It's a my Pico test synth board that has only 2 knobs, unlike the 8 knobs that the normal one has. So I have the different parameters set up in a series of pages that the top keys control. And if I press play here, hopefully you'll hear it. Can you hear it?
Yeah, that's great.
Awesome. And so here I'll play a little bit to kind of give you an example of what it kind of sounds like. So anyway, that's a kind of a close approximation of the TB303 sound, really which, cool. Yeah, it's amazing. I tried doing something similar to this about a year ago, and Synth.io wasn't quite up to it yet because its filter is not a steep enough filter. It doesn't give you that sort of squelch that that the TB303 has. But thankfully now there's a audio filters library that's just recently, and it's in like CircuitPython 10 alpha, and that lets you stack filters. And by stacking filters, you get an equivalent steeper filter, and you get some of that squelchiness that is famous in the TB303 sound. Plus, we have things like distortion and delay as other effects, and that's also key to the sound that people ended up making with these little things, because they would plug this thing into a guitar pedal that does distortion or something.
Right. So so this is all running on a Pico 2.
Yeah, Pico 2. And it actually works on a Pico 1 as well with a just a small recompile of the firmware. You don't get all the cool stuff because you start to run out of CPU resources at that point, but you get like 80% of the TB303 sound, which is pretty neat.
That's impressive. And right now, are you writing the sequences just into code, or like the note sequence, or are you able to code program that from your UI?
Yeah, no. This is just really a demonstration of the synth voice. The actual sequencer is sort of another whole thing, and then the UI to that sequencer is another thing on top of that. And so currently, all there's like 3 sequences, and they're in the code. You can select between them, but you can't change them.
Yeah. Hey, this is really cool. What's the state of this? Is this something people can see any of the current code for? The hardware is available. What's the story here?
Oh yeah, hardware's available. In fact, I'm getting a new shipment of these things in tomorrow. Thankfully, I kind of dodged some sort of tariff bullet. I think. I don't know. We'll see if DHL sends me a post shipment bill or not. Bonus, yeah. But yeah, it's a Pico or Pico 2 and a little display that's really common, and a little I2S DAC that's also really common, and then the rest are just like cap touch sensors. So it's a really simple circuit, and that's the whole point of this little board, was to make a sort of a minimal platform to experiment with audio, synth IO stuff. And yeah, it's all on my repo. I'll put a link in the Discord chat if people are interested, if they don't remember from last week.
Yeah, great. Hey, will you play us out so I can get some audio-reactive stripper shoes?
Sure thing, man.
All right, all projects now have to be duo projects.
Very good.
Thanks, Todd. That is fantastic stuff. Really appreciate you showing it and putting the effort in to get it sounding great through your OBS.
Thanks, really
man. And we will see you next time. So that is it for Show and Tell. Thanks, everyone, for coming on and showing your stuff. Thank you for coming on over to the chats and checking things out and watching the video. So we're going to end it there. We got a few minutes if you want to go grab a snack and stretch out before it is time for Ask an Engineer at 8 o'clock with Lady Ada and Mr. Lady Ada. Thanks, everyone, and I will see you tomorrow on John Park's Workshop. Bye-bye.